Moving on to problem 8, we have North American outlets supply AC electricity with a frequency of 60 hertz, while European standard is 50 hertz. So this is United States and this is Europe. Do that. Okay, and then what value of capacitance provides a capacitive reactance of 1 kilo ohm in both North America and in Europe? So we want to find C, where capacitive reactance is equal to 1 kilo ohm. Okay, and then we're going to do it for both United States and European AC electric frequencies. Okay, so capacitive reactance, we have a formula for this. 1 over 2 pi times the frequency times C, I think. Let me just double check that might be. Is that right? Yep, that's right. So then we solve for C. C is equal to 1 over 2 pi f times xc. Now we know F, we know XC, right? So let's do this for capacitance in US is going to be 1 over, what was the US frequency? 60 hertz. 2 pi times 60 hertz times 1 times 10 to the 3 ohms. That gives us a value of 2.65 microfarads. Capacitance for Europe, do the same thing, but we just change the frequency. 50 hertz times 1 times 10 to the 3 ohms, and this gives us a value of 3.18 microfarads. So for the United States, the capacitance should be 2.65 microfarads, and for the European standard, it's 3.18 microfarads, provided that our reactance is at this value of 1 kilo ohm. Next problem, number 11. Okay, we're asked what maximum current is delivered by an AC source with maximum potential difference of 48 volts and frequency of 90 hertz when connected across a 3.7 microfarad capacitor. Oh, right. Okay, so how to do this? Well, first, we want to consider that we have a relationship for reactance, right? 2 pi times FC, 1 over 2 pi times FC. So that'll prove useful here, right? And then we have Vmax, and we can relate that to XC. How can we do that? Well, we have a relationship, I think it was equation 21.6 in the summary. V RMS is equal to XC times I RMS. And this is going to be equal to V max square root of 2 XC I max square root of 2, right? These cancel out, so we're left with V max is equal to I max times XC. So then we can take this value here, plug it in here. We can take this value here, plug it in here, and then we should have what we need. Okay, so we want I max. What is the maximum current? That's going to equal V max over XC, which is, what was it, 48 volts, over 1 over 2 pi FC, which gives you 48 volts times 2 pi FC, which is going to give us 48 volts times 2 pi times 90 hertz times, what was it, capacitance of 3.7 microfarads. And if we plug all this in, we get a value of about 0.1 amps. In standard units, this would be 100 milliamps. Okay.